Hello, welcome students, and in these lectures we are start to discussions of the one another content, that is EMF, electromotive force. We are denoted as smallest letter, that is EMF, electromotive force. Electromotive force is called as EMF. And in these lectures we are just discuss what are the EMF, how can I calculate the EMFs, and what are the EMF device. When some current will be flow through the conductors, consider this is the conductors and I current will be flowing through the conductors. Conductors are flow of charges with respect to time, rate of flow of charges with respect to time. This is called as our current will be flowing through the point A to B, and the potential difference across the point or end of the conductors is potential difference V. Then this is our fundamental phenomena or fundamental knowledge about the electric current through the conductors. For the steady flow of current will be steady, could not be changes the current. For the steady current of the through the conductor, for steady flow of current, it required to maintain the potential difference across the two ends of the conductors. एखाद्या स्टेडी फ्लो करंट स्टेडी फ्लो होत असताना पोटेन्शियल डिफरन्स मेंटेन करण्यासाठी जे काही वर्क होत असते त्याला EMF म्हटले जाते. Then some work is done, this is called as EMF, and these all processes is happen in something devices. These devices is called as EMF devices. Some current for a steady current, for a steady current to maintain potential difference, that is a PD across two ends of the conductors or terminals, ends of conductors to ends of the conductors, and some work is done. Some work is done for it, for maintaining of the potential difference. For it is called EMF, electromotive force. In the higher level educations or in the next years, we are start to discuss the deeply meaning of the EMF, that is EMF, and this device is EMF device. This is the all about the definitions, meaning of the EMFs. Then charge move चार्ज स्वतः मूव होत असतात, प्रोव्हाइडेड एनर्जी फ्रॉम दिस डिव्हाइसेस, आणि त्यांना काही एनर्जी प्रोव्हाइड होत असते फ्रॉम दिस डिव्हाइसेस. चार्ज मूव ऑन provided some energy by this device, by EMF device. And the examples of the EMF device, that is battery, power cell, batteries, solar cells, fuel cells, also generators. Then I will be drawn one of the diagram here. Consider this is the positive charge and this is the negative charge, and current flowing through, and I will be apply one of the resistance here, and current carry from these directions. This is the directions of the current when they are higher potential to lower potential. Then R be the resistance I can apply across these devices, and these devices is called as EMF devices. The EMF devices are shown by the arrow. Then the EMF is shown by one of this is letter, that is epsilon. This is the representations of the EMF. Then the EMF device is shown by the arrow, and the positive terminals having the higher potential, at the positive terminals having higher potential, at the negative terminals is a lower potentials. I will be write some terms. R be the resistance and at positive terminals having higher potentials, and vice versa. Then at negative terminals is a lower potentials. I will be drawn here, that is lower potentials. At a negative terminals is a lower potential. In this point this higher potentials, and at the negative terminals they have lower potentials, and they represents the potential EMF devices represents by the using arrow, then, and this is happen in the voltaic cell, This is the all about how EMF is produced, how EMF will be work, EMF device will be work, and what are the provided. They are provided some energy for the carrying, for the moving of the charges. Then charges move on by the provided some energy by the devices. And now we are start to solving the equations for the calculating of EMF, electromotive force, EMF. Then let's start. The positive charge moves had lower potential to the higher potentials. Then a positive charge is moves to lower potential to the higher potentials. Positive charge moves lower potential to higher potentials. The positive charge will be moves from the lower potential to the higher potential. Then this positive charge is moves towards to the positive terminals inside the EMF terminals, inside the EMF devices. This is the positive terminal, this is the negative terminals. Then the positive charges are moves the lower potential to the higher potential inside the EMF devices. म्हणजे EMF devices मध्ये पॉझिटिव्ह चार्ज हे काय करतात, पॉझिटिव्ह टर्मिनल कडे येत असतात, आणि निगेटिव्ह चार्ज हे निगेटिव्ह टर्मिनल्स कडे ऑब्वियसली जातच असतात. दॅट इज इलेक्ट्रॉन्स विल फ्लो. देन द फ्लो ऑफ चार्जेस with some time dt, the flow of charges, that is dq, with some charges, flow of charge dq with some time, that is dt. Then the current is rate of flow of charges with respect to time. This is for the equations for current. And in the entering the negative terminals leaves, it is enters in the negative terminals and leave from the positive terminals. The charges will be enters at a negative terminals and leave from the positive terminals. The device must be some works. The device in the devices must some work when the charges will be flow and work will be done by the when a potential difference is applied. We will be potential difference across it, then the work will be some work is done. The devices must do some work of d omega. The devices must do some work, that is must do some work, that is d omega. The devices must do some work, that is d omega, on a charges that is dq will be flow, on a charges flow in presence of EMF, in presence of EMF. Then we define the EMF if epsilon is equal to, EMF is equal to work done per charge. This is the EMF. In the starting of these lectures, we are said the current will be flowing through the conductors, charges will be flowing. To maintaining this, to maintain the some potential difference, we required some work will be done. Then it is happens, and this for a steady current, to maintain the potential difference across the two ends of the conductors, some work is done for it. This is called as EMF. Then some work is done, flow of current, and for current will be steady for the maintaining of the potential difference. And this is about the SI units of the EMF is joule per coulomb. Joule per coulomb, that is J by C, joule per coulomb. And in an ideal device, no internal resistance when the motions to the motions of the charge carrier in the EMF is equal to the potential differences. Potential differences remain same when in the ideal devices no internal resistance, R will be no internal resistance, then EMF is equal to the potential difference. EMF is equal to potential difference. Then I will be write one of the sentence here. In ideal device, no internal resistance, then the EMF is equal to potential difference. EMF is equal to potential difference. But in the presence of, in the real device, this is the ideal devices, no internal resistance, then in EMF is equal to potential differences. In the current will be steady, same current will be flow, and same applying this is the law V is equal to I into R. Then this is not happen, or resistance will be absent, the potential difference is equal to electric current. And for the steady current, EMF will be produced, then potential difference is equal to current, then this is also is equal to I. Then if a current will be flow through, the I will be current flow through in a real devices. In a real devices, it have some resistance, internal resistance, such as not connected in current will be not flowed. This device, real devices will be not connected, then current will be not flowed. Then consider, or let, I will be use these portions of the board for the solving one of the derivations for EMF, for the equations of EMF to calculate Consider, let current I will be flow through the real devices, and small r be the internal resistance, small r be the internal resistance. Then the EMF epsilon is different from the potential difference V. Then induced EMF is a difference or changes, differs in some potential difference that is V. And now I will be start to applying the Ohm's law. Then the V is equal to, potential difference is equal to, in this form, then epsilon induced EMF is equal to, it is I current flowing through it, and this is the R resistance, internal resistance. And now I will be use Ohm's law. By Ohm's law, then V is equal to I into R. Then consider this is the equation number 1 and this is the equation number 2. Then we are observe the both equation 1 and 2. The left hand side of both equation will be equal, and obviously right hand side will be equal. Then IR is equal to epsilon minus I into R. Then this negative sign will be difference. This negative sign, the charges will flow through the lower potential to the higher potentials. Charges will be flow from the lower potential to the higher potentials. And now I will be calculate the current I R plus I into R is equal to epsilon. Then I is equal to this is the epsilon divided by, I will be take the common of the I, then I will be write these equations like this, I into R plus R is equal to epsilon. Then the I is equal to R plus small r. This is the, I will be taken resistance, then this is the smallest internal resistance. For the maximum values, maximum current, then I max is equal to epsilon divided by R. Sorry, it is used, this is small r, internal resistance. This is all about EMF. How will we produce EMF, and what are the EMF, and what are the EMF devices, and we are start to calculate in the form of EMF devices. When the current will be used and internal resistance will be used, then we find the EMF, how much EMF will be produced in the given circuit.